In this video, we're going to be using the reciprocal and quotient identities to find values of other trigonometric functions. So let's remind ourselves what the reciprocal and quotient identities are. So our reciprocal identities would be that the sine of theta is 1 over the cosecant of theta. The cosecant of theta is 1 over the sine of theta. Cosine theta is 1 over the secant of theta. Secant of theta is 1 over cosine theta. Tangent of theta is 1 over cotangent theta. And cotangent theta is 1 over the tangent of theta. For quotient identities, we have that the tangent of theta is the sine of theta over cosine theta. And cotangent, because it's the reciprocal of tangent, would give us that the cotangent is the cosine of theta over the sine of theta. And we can actually rewrite those as tangent theta times cosine equals sine of theta, and sine of theta times cotangent of theta equals cosine theta as well. And those can come in handy. Let's get back to our problem. So here we're given that the sine of alpha is 5 over 8, and that the cosine of alpha is radical 39 over 8. And we're going to use the reciprocal and quotient identities to find the values of other trigonometric functions of alpha. Now, given the values of the sine of alpha and cosine alpha, we can use the quotient identities to find our tangent of alpha and our cotangent of alpha. So remember, the tangent of alpha is our sine of alpha divided by the cosine of alpha, and we have both of those values. So we're able to write this as the tangent of alpha equals 5 over 8, because that's the sine of alpha, divided by the square root of 39 over 8, which is our cosine of alpha. And now we just need to kind of do the math there. So we're going to have 5 over 8, and we're going to divide by square root of 39 over 8, which is going to give us 5 over 8 times the reciprocal, so 8 over radical 39. So our 8s are going to cancel out there, and that's going to give us 5 over the square root of 39. And now we just need to rationalize our denominator. So as we rationalize our denominator, we're going to multiply both sides by the square root of 39. When I say both sides, I mean the numerator and the denominator. And that's going to give us a 5 radical 39 over 39. And so that's going to be our tangent alpha. So let's go ahead and let's take a look at our cotangent. So remember that cotangent of alpha is just the cosine of alpha divided by the sine of alpha. So we can then say that our cotangent of alpha is going to be the square root of 39 over 8, all divided by 5 over 8. So we work that kind of the same way we did the last one. So the square root of 39 over 8 divided by 5 over 8. And that's going to give us the square root of 39 over 8 times 8 over 5. Again, our 8s are going to cancel out. And this is going to give us the square root of 39 over 5. And we don't need to worry about trying to rationalize this because it's already been rationalized. So this is going to be our cotangent of alpha. Now the other two things we need to find is the cosecant and our secant. So the cosecant of alpha is supposed to be 1 divided by the sine of alpha. So if we take a look at that, that's going to give us 1 over 5 over 8, which is 1 divided by 5 over 8, or 1 times 8 over 5. And so we can see that our cosecant of alpha is going to be 8 over 5. And then lastly, we need to find our secant of alpha, which is 1 divided by our cosine of alpha. And so we're going to have 1 divided by the square root of 39 over 8, which is going to give us 1 divided by the square root of 39 over 8. And we're going to rewrite that as 1 times 8 over the square root of 39, which is going to give us an 8 over the square root of 39. And so then from there we need to rationalize because we don't want to leave a radical in the denominator. And that's going to give us that we have a secant value of 8 times the square root of 39 all over 39. And so here, remember, for tangent and for cotangent, we use the quotient identities. And then for the reciprocal, for cosecant and secant, we use the reciprocal identities.